All right, welcome back. Now that we've learned about this encoding stuff, let's learn how we can populate this parentheses, this data field, so we can call any function and we can do essentially what the blockchain is going to do at the low level. We can work with just that binary. We can work with just that bytes. We can work with that hex to interact with our smart contracts. So let's create a new file and we're going to call it callanything.sol. Start off with SPDX license identifier MIT, and let's talk about this. Now, in order to call a function using only the data field of the call, we need to encode the function name and the parameters that we want to add, right? Because when we call a function, we call the function name and we call the parameters. So we need to encode these down to the binary level so that the EVM or these Ethereum-based smart contracts, the Solidity stuff, can understand what's actually going on. In order to do this, we're going to need to work with two concepts. To encode the function name so that the EVM or Solidity can understand it, we actually have to grab something called the function selector. Now, the function selector is going to be the first 4 bytes of the function signature, and the function signature is just going to be a string which defines the function name and parameter. Now, what does this actually mean? Well, if we have a transfer function, this right here is known as the function signature. So the function name is going to be transfer, and it's going to take an address and a uint256 as its inputs. If we encode this transfer function, and then we take the first 4 bytes of it, we get this, which refers to the function selector. So that's how Solidity knows. So in the byte code, in the binary code, this function selector is how Solidity knows, oh, they're talking about the transfer function. They want me to call the transfer function. And this is one of the first things that we need to use call to call any function that we want. We need to get the function selector, and we can get it a number of different ways. But one of the ways is by encoding the function signature and grabbing the first 4 bytes. So we'll create this contract. We'll do pragma solidity 0.8.7, say contract, call anything. And we'll give this 2 storage variables. Give this 2 storage variables an address, public s underscore some amount or some address, and then uint256, public s underscore amount. And then we'll create a function called transfer, function transfer. Now, normally in here, we would actually do like transfer for like an ERC20 transfer, but we're just going to do address, some address, and then uint256 amount here. We'll make this a public function. And then all we'll do is we'll set s some address equals some address, and then s amount equals amount. So here's going to be the function that we're going to work with. And the function selector for that function is this. The function signature is this. So it takes an address, some address, amount, that gets boiled down to the function selector and the function signature. And of course, in our bytecode, there's going to be some code saying, okay, here's what this function does, blah, blah, blah. So we can actually even write a function to get that function selector. So we can say function get selector, and I'm going to say get selector 1, because I'm going to show you a few ways to get the function selector. We'll make this a public pure, and we'll have this return a bytes for selector. We could say selector equals bytes for, and then we hash with check 256 of the bytes of that signature, which is transfer, and it takes an address and a uint 256. All right, if we compile this and then we run it, let's get rid of our old contract, deploy, make sure we're on call anything if you have the other one up. And here now we have a couple of things. If we hit get selector 1, we get this OXA905 blah, 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 right? And that's the same as the example I just gave. So this right here tells Solidity, tells our smart contract that, okay, when we make a call to this contract, if you see this in the function data, this is referring to our transfer function with an address and a uint256 as input parameters. So we see address, uint256, our function knows to execute this data here. Great. And then of course, s amount and s address are zeros. Now, while we're here, we can also see, okay, what happens if we call the transfer function, right? It takes an address and an amount. So let's just give it its own address for an address, and we'll do 777 for an amount. If we hit transfer, we have the log up, right? We'll get a little check mark here saying success. Now, if we hit s amount, we'll get 777, and then the address will be the same, right? So that's us directly calling transfer. When we directly call transfer, we're basically saying, hey, grab this function selector and then do some other stuff, which we'll tell you the other stuff in a minute. Now we have the function selector. Okay, great. What else do we need? We also now need the parameters we want to add. So we're going to need to encode those parameters with our function selector. So what we're going to do is we're going to say function get data to call transfer. And in here, we're just going to have this get data to call transfer. We're going to have it take these input parameters and we're going to encode these to work with our function selector. So we're going to say address, some address, even 256 amount, public pure returns, bytes memory. And then we can return and use one of those ABI encodings from the cheat sheet. Now, so far, we've just been doing ABI encode for a lot of our encoding. So since we have the function selector, we can actually do ABI.encode with selector. This ABI encodes the given arguments starting from the second and prepends the given 4-byte selector. When we do encode with selector, we're just sticking our selector onto the data that we're going to give it. So we're going to do return ABI.encode with selector, and we're going to pass it the result of get selector 1, and then we're going to give it some address and amount. So what this is going to do, it's going to give us all the data that we need to put in that data field of our transaction to send to this contract to let this contract know, hey, go use the transfer function, pass in some address and then an amount. And then if we compile this, we run it, let's delete our old contract, we'll deploy it. We now get a new function called get data to call and transfer. We'll just pass, this contract's address, and then we'll also do 777 again. And so this thing right here is what we're going to put into the data field of our transaction in order for us to call transfer from anywhere. So this is the bytes, this is the binary encoded data of, hey, call the transfer function with this address that we specified with, 777 amount. So what we can do once we have all this, we can actually call our transfer function without even having to directly call it. So what we can do is we can say function call transfer function directly, or I guess with binary might be a better title, but you get the gist. We'll say address, some address, UN256 amount. So we'll make this a public function, and we'll have it returns a bytes 4 and a bool. You'll see why in a minute. And we'll do that same call thing that we did to send our raffle money. So what we'll do is before we did recent winner.call, right? We're going to do some address. And then for us, we're going to do address this.call. And then we're saying this contract's address, which we could put any address here, address.call. And we're going to call the encoded data that points us to the transfer function with some parameters. So we're going to do address this.call. And we could just do get data to call transfer, some address amount, right? We could do it like this, or we could do it kind of the raw way. We could do ABI.encode with selector, get selector 1, comma, some address, comma, amount. And actually there's no semicolon there, sorry. So those are going to be the same. And this dot call thing, right? It's going to return exactly what we saw before. It's going to return a bool success. So whether or not the transaction was successful, and then bytes memory return data, which is going to be, whatever the call returns. So, right. And this is where we put like require success, right? But for us, we're just going to return bytes 4 of return data, and then success. So we're just going to return the first 4 bytes of whatever data we get returned. And then we're going to return whether this was successful or not. So this function is going to have us directly call the transfer function by passing these parameters without us having to do like contract.transfer or transfer, whatever, right? And you could do this across multiple contracts, across different contracts, just by changing the address that you call on. So let's go ahead and compile this. We'll run this now. We'll delete our old contract. We'll deploy call anything. Now, if we were, so right now S amount and S some address are both 0. Now, if we do call transfer function directly, and we'll pass in this one's address, and then we'll do 777. Now, if we pull up the logs, we hit this, we're going to get this transaction response here. But if we scroll down, we'll be able to see the decoded output, which is a bytes 4 of just a bunch of zeros, right? Because our transfer doesn't actually return anything. So it's just going to be a whole bunch of zeros. And then our Boolean true, which means it was successful. So since it was successful, these two should have changed based off of that. So let's go ahead and try them out. And we do indeed see that they're changed. So we have just directly called this transfer function without having to call the transfer function itself. We can also do encode with signature instead of selector. So if we go to our cheat sheet, there's also this encode with signature down here, which takes the string memory signature and it's equivalent to doing abi.encode with selector, bytes for, kcac, bytes, signature. It's equivalent to doing exactly what we did up here, but it does this step for us. So we could copy this whole thing, paste it down here, right? And we could do, instead of encode with selector, we could do encode with signature, the function signature, and then we'll copy our function signature from up here, paste it in here, compile. We ran into a compilation error. Oh, these are the same. Call transfer function directly sig. I'll call it that. Compile, delete our old contract, deploy. Now these two are both zeros again. Now if we copy the contract address, we do call transfer function directly sig. We paste that in here. We do 777. We call it, then we check these. We can see that that does the exact same thing. So this is abi.encode with signature. This is abi.encode selector. Encode with signature just turns this into the selector for us. That's all. Up here, we encoded the selector ourselves. Now there are a whole bunch of different ways to get the selectors, and we're not going to code these out ourselves. I'm just going to say a bunch of different ways to get selector. And who knows why you might want to use one of these other reasons, right? There's a ton of reasons why you might want to get the selector a different way. And here's some. Now in this video, we're not going to explain or go over all these different function selector getting methods. But if you go through them in the GitHub repo associated with this course, they all have a ton of comments to explain what they're doing. What we are going to show you though, is actually how two contracts can interact with each other without actually having all of the code for each contract. So we're going to make a second contract that has all this binary, this bytes information to call the transfer function on a different contract. And we're going to show you how that can work. This is just another contract that I made called call function without contract. Actually down here, we're going to call the transfer function just by using the address and the function selector signature and stuff. We're going to update these storage variables in our call anything contract from another contract just by doing this binary calling, if you will. Right, so let's compile. Let's go to deploy. We can actually leave this up, right? We can leave this up. Let's deploy our call function without contract. We'll pass it as an input parameter. The call anything contract address. We'll deploy it. Now in here, I can call the transfer function directly by, maybe I'll switch it to this contract address, this new contract address, and we'll give it a new number of 123, right? And we'll click call transfer function. And then when we go back up here, we see that this has indeed been updated. Now doing this call stuff is considered low level. And it's a best practice to try to avoid it when you can. So if you can import an interface, it's much better to do it like that because you're going to have the compiler on your side. You're going to be able to check to see if your types are matching and all this other stuff. So usually doing these low level calls, some security auditor checkers might say, hey, this spooks me out a little bit, you doing this low level stuff. But with that being said, you have just learned a ton about lower level Solidity. This is some really advanced stuff. And like I said, if this was hard, if you're kind of confused here, don't worry. You can always come back to this section and try it again when you're a little bit more advanced. If you want to try to understand it all now, awesome. Absolutely. We've left some links in the GitHub repo associated with this lesson that I definitely recommend you check out. One of the ones you should definitely check out is going to be this Deconstructing Solidity by OpenZeppelin. It really breaks down exactly what's going on behind the scenes of a contract. If you want to learn more about opcodes, about low-level stuff, definitely give this a read. It is a phenomenal read. Essentially, it breaks down a little bit more than what we went over here. A couple other videos as well, and I've left a whole bunch of links in here too.